Good day everyone. Welcome to Azure Databricks series. In today's video, we'll walk you through setting up compute and managing clusters step by step. From driver and worker types to single versus multi-node clusters, auto-scaling and photon acceleration. I've got you covered. If you're ready to level up your Databricks skills, be sure to hit the like button, subscribe to the channel and ring the bell icon so you never miss an update. Let's get started. I'll be launching the Databricks workspace. Okay, so we have the Databricks workspace here. What I'll do now is let's click on compute here. And here, what I'm going to do is I don't have any compute created in this Databricks workspace. So let's click on create compute. So we will leave this policy as unrestricted, yeah, and then we will have this multi-node, yeah. So if you see here, when you have multi-node, then you can have multiple nodes for your worker, and you can have a separate node for your driver, yeah. Now if you click on single node, yeah, so what happens is you will just have one node, and that one node will be utilized as both your worker and also as your driver, and there is no way you will be able to have multiple nodes as far as worker nodes are concerned. So it will be just one node that will act as both worker and driver. Now if you use multi-node, what will happen is you will have a separate a node for your driver and separate nodes for worker. We'll talk about this driver and worker more elaborately when we come here. But as of now, just understand if it is going to be multiple node, you will have several nodes, multiple nodes, one node for driver and several nodes for worker. Yeah, and single node. Both your driver worker will be one node, and it will be just one node that will be utilized by your Databricks. Yeah. Now we will go up. We will go with this multi-node, and as far as the access mode is concerned, we have options like single user, all languages, yeah, and shared Python and SQL is allowed, and no isolation shared, all languages, yeah. So here I'm going to use single user, yeah, but in production deployment it will mostly be shared, yeah, so that you can have multiple people sharing the same cluster, yeah. Let's use the single user which we'll be using, yeah. And Databricks runtime version, you have this many versions here, yeah. I will select 15.3. The reason why I'm selecting 15.3 is in later videos I will show you guys how easy for us to move from one version to another version, yeah. But as of now I will select 15.3, but it is always advisable you go with the latest version, yeah. But here I will use 15.3. Yeah. So the next comes your photon acceleration. Let's see what is this photon acceleration. Photon accelerates modern Apache Spark workloads, reducing your total cost per workload. Yeah. So what happens is if you check this option, the understanding is the overall time taken to process your notebooks is going to be very fast, yeah. But the thing is the thing to keep in mind is it is costly as well. It can be sometimes very expensive, yeah. So I have seen scenarios where we have enabled this photon acceleration, and we were able to see some better performance, yeah. But the bill associated with that was kind of little expensive, at least for us in that scenario. So it was quite expensive, at least for us. Yeah, I'm not telling it is going to be expensive for everyone. It is all case-to-case basis. But in my case, when we deployed this, we thought like it was quite expensive. So what we did is like we tried our workload with and without photon acceleration, and what we were able to see is like without photon acceleration, the time taken was acceptable to our business. Yeah, so that way, what we thought is like we will not use photon acceleration, and that way we were able to reduce. Cost associated with enabling the photon acceleration. So what I would suggest to you guys is like you guys have to test with and without photon acceleration, and you need to come to a conclusion whether without using photon acceleration, whether the performance that you guys are getting is fine for your business. If it is fine, then what I would suggest is like you definitely have a solution in your hand whether to use or not use photon acceleration. Yeah, in our case, we tried both option and then we picked up which one is good for us. Yeah, so yeah, now, if you look at the worker type, yeah, so if you see this worker type, we have auto scaling enabled here. If I disable the auto scaling, yeah, so what happens is like we have a fixed number of workers. So workers in the sense, what happens is like you will see this many number of nodes that will be created. If you want, you can definitely reduce it. Yeah, so you can reduce it to whatever workers you feel would be fine for your workload. But yeah, but I will leave it as enabled, auto scaling enabled. And what I'll do is like instead of two minimum workers, I will select as one, and maximum workers instead of eight, I will put it as four in my case. Yeah, but in production, based on your requirement, it is always good to have the minimum workers as two, and maximum workers, maximum you can have eight. Yeah, so if you see here, let's try increasing it. Yeah, so you can have this many, but you can have whatever is fine for your business requirements. Yeah, so here as of now, what I'm going to do is like I'm going to have the min workers as one and maximum workers as four. Yeah, and driver type, have mentioned like by default it is same as worker. Yeah, so if you see here, what we are basically seeing is like in case if the workload is not there or it is very less, then what happens is like the Databricks decide how many workers it would require. Yeah, so driver can be considered as the master, yeah, and worker can be considered as a slave, wherein the driver basically provides the work to the workers, and then once the worker completes the work, then the driver picks up the work and then gives it back to the user. Yeah, so that is how it is designed. But in this case, what happens is like let's consider we have a very busy workload that is coming in, and what can happen in our case is like each node here is like configured with 4 cores with 16 GB memory. Yeah, so that means like let's consider we are going to have four workers. So let's consider our Databricks is busy. The workload that has come in is resource intensive. So that, and let's consider like Databricks has auto scaled to four workers. Yeah, because we have the max worker set to 4 here. So that means like you will have 4 into 4 cores, that is 16 cores, and 4 into 16 GB memory, which is going to be 64 GB memory, and then additional 16 GB memory for your driver, and then 4 cores for your 4 cores for your driver. Yeah, so that means like it's all together 20 cores when you are at the maximum when you're using 4 max workers. So that means like you will have 4 workers plus one driver, which is going to be 5 nodes. Yeah, 5 nodes. So that means like you will have 20 cores, and then you will have um, uh, 64 plus 16 would be like 70, close to 80 GB of memory. Yeah. Okay, so with this one, what we have selected is like we have selected one min workers and 4 max workers, and we have this driver node as well. Now, if you look at the summary, it basically tells like 1 to 4 workers would be like 16 to 64 GB memory, and 4 to 16 cores. Yeah, now if it is going to be one worker, then it would be like 4 cores and 16 GB RAM for the worker. And if it scales, auto scales to 4, then you will have 16 cores and 64 GB memory. And as far as the driver is concerned, it will be fixed to 16 GB memory and 4 cores. Yeah, now altogether the calculation comes as, like, for example, if there is an auto scaling of 4 workers, then the overall setup, node setup, would be like 20. You will have 20 cores, yeah, because it is 4 workers and one driver, which is 5 nodes, so 20 cores, and then you will have like 80 GB of memory. Yeah. So as of now, I will utilize standard T4 DS underscore V5 machine. So now if you see here, there are so many options available. The minimum one is like 4 cores and 64 GB. Yeah, there is one more with 4 cores and 14 GB. So you have a lot of options here. Yeah, you can select as per your requirement, but I will leave it to this one. Yeah, so now let's consider you had like close to max workers as 4 and min workers as 1, and then if you feel like the workload requires more resources, what you can do is, like, you can change this max workers to a higher value, or what you can do is, like, you can increase the existing specs from 4 cores 16 GB, 4 cores and 16 GB memory to a bigger machine. Yeah, and then slowly increase the things as per your requirement. Yeah, so I spoke about auto scaling, how auto scaling is going to enable auto scaling, wherein dependent on your workload that is coming in, the number of worker nodes will increase between 1 to 4. So whatever you have mentioned here, it basically moves from 1 to 4. Now let's consider highly resource intensive workload comes in, and then auto scale basically scales up to 4 workers. And once the workload completes and your Databricks workspace goes, that is, the compute goes idle, or let's say you have fewer workload coming in, then what happens is, like, auto scale also reduces 4 workers to the minimum workers required for a proper functioning of the Databricks workspace. Yeah. So terminate after 120 minutes of inactivity. So what happens is, like, whatever minutes you give. For example, if there is an inactivity, then what happens? Then the cluster basically stops after this many minutes of inactivity. So in my case, I'm going to change it to 10, but in production, 10 minutes is very less. You basically have to definitely change it across to a value that is appropriate for your requirements. Yeah. So tags, what I'll do is, like, I will add it as environment, prod, owner. I will add my name here, workspace, yes, wiki, Databricks. Yeah, so let's add these tags here, and then everything else should be fine. Let's look at the automatically added tags. The tags are vendor. We have this creator here, and then the cluster name, and you will see the cluster ID after this cluster is created. Yeah, and let's look at the advanced options as well. So we have these advanced options. We will look into these things later, but as of now, these are the details as far as creation of the initial cluster is concerned. Yeah, let's click on create compute, and let's wait for this compute to get created. Okay, so the cluster is created now. Yeah, let's click on compute here. So if you see here, you're able to see that the cluster is running. Yeah, runtime is 15.3. So active memory is 32 GB. That is 16 GB for your driver and 16 GB is for your worker. So altogether you have two nodes. Yeah. And active CPU cores, it is four cores for your driver and four cores for your worker. Yeah. So we have these details here with the creator and things like that. Yeah. So now what we'll do is like let's head to our workspace here. Yeah. And then what we'll do is like let's go to this manage resource group. Yeah. If you look at the manage resource group, yeah, as of now we know like there are two virtual machines created, yeah. So if you see here, there is one virtual machine that is created, and this is the operating system is Linux, Ubuntu 20.04. Now look at this size here, yeah, which is 4 vCPUs and 16 GB memory, yeah. So now if you see here, we have this cluster name and if you look at this, this is the one that we have created. So this proves that this particular virtual machine, which is on the managed resource group, is part of our cluster. Yeah. And let's look, and there is one more virtual machine like that. Yeah. So because as I told you earlier, we don't have any workloads currently running on this cluster. So that means like we have two nodes. That is one node is for your driver and one node is for your worker. Yeah. So this one also is a standard D4 DSV5, 4 vCPUs and 16 GB memory. Yeah. And now if you look at the cluster details here, the tags, you can see that the cluster name is this one, yeah, which is same as what we have created. That's it for this video. Thanks for watching. Have a great day. Jai Hind.